Chemistry students, welcome to today's lab 1-10. Today's lab is on physical versus chemical changes. In our class notes 1-7, we learned that there are physical properties and chemical properties, and there can also be physical changes and chemical changes. In today's lab, we will be exploring an opportunity to watch those processes taking place, physical changes and chemical changes, and we need to make conclusions as to whether what we are watching in the video is a physical or chemical change. So this is a video lab today, but nonetheless, safety is always first. Please be sure to wear your safety goggles as you're watching these chemical reactions, because we'll be watching chemical reactions involving acids and other compounds which can be very dangerous to your eyes. Likewise, the chemicals used in this experiment can ruin your clothes. Acids and so forth can put holes in your clothes. The other chemicals can stain your clothing, so wearing a lab apron over your clothes if you are wearing nice clothes today, or simply taking a moment to pause and go change into some clothes that are expendable. After today's lab, be sure to wash your hands excessively using soap and water. Say the alphabet forwards, backwards, then say the alphabet again with lowercase letters, and then one more time backwards using uppercase letters, and perhaps one last time of washing, saying the alphabet with cursive letters. And then you do that, and you'll probably have washed your hands long enough with soap and water. Again, this is a video lab. Safety is always first. Before we talk about what we're doing in today's lab, let's remind ourselves of what physical and chemical changes are. This is referring back to our 1-7 notes. There are properties of matter, and properties of matter can be classified multiple ways. One way to classify them is whether the property is extensive or intensive. Extensive properties matter on how much is there. So if you add more to it, the property would change, or the amount would change. If you remove some from it, the property would be lowered or change. In other words, extensive properties deal with things that you can measure. If you add more pennies to the pile, the mass goes up. If you remove pennies from the pile, the mass goes down. That would be extensive. Likewise, the more pennies you put in a graduated cylinder, the volume would go up. The fewer pennies you put in the graduated cylinder, the volume in the cylinder would not go up as much. Those would be extensive properties. Intensive properties are things that you can merely observe or you can measure, but it doesn't matter how much is there. So today we'll probably have an opportunity to see mostly intensive type properties in today's lab, because in today's lab we are not making measurements as you would in determining extensive properties. Speaking of properties, we can classify them other ways as well. There are physical properties, and then there are chemical properties. Physical properties are things you can observe without changing the substance, without reacting with other substances to see how it's going to behave chemically. Chemical properties do relate to how it behaves chemically. When you're exploring chemical properties, you will need other substances to react it with, and you're going to see how it behaves. Types of reactions might be, does the substance react with water? If you put it in water, does it react? Does the substance burn? Does it react with oxygen? Does the substance rust, which should also be reacting with oxygen? Does it react with acids, as we're going to use today in the lab? We'll see that some substances react with acids. Anytime you put two substances together with the purpose of seeing, is a new compound going to be produced? Is something going to happen chemically? You are exploring chemical properties. Chemical properties, when you're exploring them, means that a chemical change will occur. Today, we're going to have to watch for evidence of chemical changes occurring. That's essentially what this lab is about. Looking at evidence. Evidence doesn't mean it definitely happened. So if you see evidence of a chemical change occurring, it doesn't mean it happened. But the more evidence you see, the more likelihood it was a chemical change. Chemical changes would involve things burning, where you see flames coming off of it, or burning, where you see smoke coming off it. So today, if you see flames or you see smoke coming off of it, that's possibly a chemical change, most likely a chemical change. If you see the generation of bubbles as the substance starts fizzing, or bubbles being produced, that means you put two things together and the reaction ended up resulting in a product that was in gas state. If you see a precipitation reactions where you put two solutions together. A solution is something where a substance has been dissolved in something else. That's what a solution is. Something's been dissolved in something else. So when you put two solutions together and the substances that were in that solution, if those substances react and join together and are no longer able to remain in solution, they will precipitate out. Not everything dissolves. So some chemical reactions will have two things join up to form a new compound which doesn't dissolve, which is not soluble anymore. Soluble refers to doesn't dissolve. If you see color changes, that can also be evidence of a chemical change. A flash of bright light can be evidence of a chemical change. But not on this list, but most likely should be on this list, would be the generation of heat energy, which means it's producing heat energy. It might not always be a flame. It might be just heat escaping or being released. That's an exothermic reaction, an exothermic chemical reaction. Chemical changes can also involve endothermic reactions where they take in heat energy and they would feel cool to the touch. So chemical changes, one of the best evidence that a chemical change is occurring is a change in the heat. If heat energy is given off, it's exothermic, it would feel hot to the touch. If heat energy is being taken in, that is great evidence that a chemical change is occurring. That would be endothermic. Endo means in. Heat energy moving in, it would feel cold. So we're looking for this evidence. When you see evidence of these things happening, the more of these things you see happening, the more likelihood that a chemical change is occurring. How would you know if a physical change is occurring? Well, you're not going to see any of that evidence of the chemical changes occurring because the substance you start with is going to be the substance you end with. Examples of physical changes could be dissolving something in water. If you take salt and pour it in water, the salt dissolves in the water. The water pulls apart the salt. The salt is still there. It hasn't changed into another substance. Table salt is sodium chloride. If you pour sodium chloride in water, it just pulls apart the sodium ions and the chloride ions. They're still floating around. It's now salt water. You've made a mixture. You can get that salt water very easily by evaporating away the water. The salt would be left behind. You could the process of changing the liquid water to water vapor, liquid to gas, that change right there is also a physical change, changing the state of matter of that substance. You start with liquid water, you evaporate it, it becomes gaseous water, it's still water. And the stuff you would be left behind with is the salt. You still have the salt, you still have the water, you did not have a chemical reaction occur because if it's a physical change, the stuff you started with is still there. It has not formed a new compound. Changing the shape of something doesn't change what's there. That's physical change. As we mentioned, changing the state of matter. If what you start with is what you ended with, that is a physical change. So those are some physical changes. Changes in solubility, size, state. Those are all beginning with S's. A way to remember physical change is what you start with is what you end with, and they all start with S's. Changing the size of something, breaking it into smaller pieces. If you have a glass window and the window breaks, you still have the glass. You've just changed the size. It hasn't changed into anything new. Now notice that a change of the state of matter, producing a gas or a liquid freezing back to a solid, water freezing into ice is a physical change. It's easy to confuse it with chemical changes. Chemical changes can produce gas as well. fizzing and bubbling. But the gas you produced in a chemical change was not there when you started. Two other substances joined up to make that gas. That would be chemical. The formation of a solid precipitant. That solid was not there before. It's something new that you formed. So if what you formed is a new product, then it's a chemical change. If it's the same thing undergoing a change in state, then it's physical. So that's just a little background. Today we're going to be seeing demonstrations of both physical and chemical changes. Look for those. In today's lab report, we will be witnessing those things occurring, and we will make observations. Right now you are watching video number 137, which is the introduction. From here you're going to proceed on and do the lab. The link to the lab is right on our lab sheet. Watch the video. It will take you through a series of things, and you will merely be recording observations. At the end, you will decide if what you saw was a physical or chemical change. An answer key is going to be posted below as well. It's right down here. If you look under the lab, there's your answer key. When you're done, compare your work to the answer key to see if you are agreeing with what you saw, and it'll help you check your level of understanding. We're now taking a look at the actual lab report. This again is attached. Here's your link to watching the video. It's an outstanding video made by the great experimenter Eric Pantano. I think you'll enjoy this video. It is only 14 minutes. As you watch the video, you're going to be seeing a series of things taking place. The first thing he does is right here. You'll watch it and answer these questions, recording your observations. Then you'll watch the second thing, record your observations by answering these questions. Then there's a third thing he's going to do, involving magnesium metal. Record what you see. Then we're going to see a fourth thing, 2 steps to the fourth thing, again involving magnesium. Then you're going to see a fifth demonstration, 6, 7, 8, 9. You're going to actually see 10 things done in the lab, and you're going to make your observations right here. There are no calculations, so you're just going to be watching, You're not actually going to be measuring things. So you're going to be making qualitative observations. You're going to be looking for the qualities of what you see. No measurements. Measurements, again, are quantitative observations. But at the end of the lab, you'll decide if each of those actions that you saw were physical or chemical. You'll write physical or chemical right in here, and then you'll explain why you made that conclusion. That is today's lab report. Again, when you're done, compare it to the answer key to see if there's some agreement, and maybe you can check your level of understanding. As always, if you have any questions, do not hesitate to ask during a Zoom meeting, or come in and sign up for some office hours, and we'll have a Zoom meeting, office hours, so that you understand the difference between physical and chemical changes. Enjoy the lab.